Hi everyone, in this video we'll solve this problem product of array except self. Let's read the problem statement first. The problem statement says we are given an integer array nums. We need to return answer, so that answer of I is product of all elements except that nums of I. And this product of any prefixes and suffixes is guaranteed to be in 32-bit. This is not important in Python, but this is good to know that overall product might not be in 32-bit, but the prefix and suffixes could be, and we need to write it in order and we can't use division operator, right? So we are tracking this in Blind-75 list. So this is using two traversal technique. I put the link of this sheet in the description below. So before solving the problem and visualizing it, let's read the quote of the day. So it says, work hard in silence, let your Lamborghini make the noise. So the basic idea is, okay, whenever you are worried about anything in future, or somebody not responding to you properly or anything, like you have anger about anything, just put all your anger for your work, put it in your work, not for your work, but put it in your work. Work hard in silence, everything will figure it out, everything will get fixed with time, right? So just focus on your work, don't worry about anything else in life, right? Okay, so let's jump to the visualization. So the first idea is that can come to our mind is, okay, like the basic idea one is I'll say, okay, let me pick the pen first. Yeah, so the first idea is I'll say I will take the which is not following this constraint, but still let's go to solve this using that techniques, right? So in the first idea, what I can say is take product of all. I'll take product of all the elements, and then we'll take division, right, with the n of I while iterating, right? So what will happen in that case is I'll take the product, right, entire product, 4 into 3 into 2 into 1, everything, right? But this is not following the constraint that maybe it will go outside, right, outside the limit. And second thing is we will be using division operator in the second iteration. When we have, let's say, 24 here, we'll divide 24 by 1 and 24 by 2, 24 by 3 and 24 by 4. Apart from that also, you can't even make it work correctly. Why? Because there is a zero present. Let's say the moment there is some zero present here, right, what you'll do is you'll take the entire product, it will become 0. So for everything you'll be dividing 0 by -1, 0 by, but this will be 0 by 0, but actually the answer should be everything except zeros. Even though we can work it out, the way we'll do it is, I think rather than writing this brute force, what I'll do is I will write this 1.2 solution, which is, okay, I will count the number of zeros. Okay, I will count the total number of zeros, and if this zeros is greater than 1, then everything should be 0, right? Because for that, somewhere the prefix will be 0 for each element, right? So the overall prefix or suffix will be 0, so the overall answer will be 0 for everything. But if zeros, there is 1 0 present, okay, except that element, everything else should be 0, right? So in this case, everything else except 0 should be 0. Okay, so oh my god, I can't even read my handwriting. Okay, anyways, so now in the next solution, which is, okay, let's follow all the constraints. What I can do is, okay, let's think about it. What exactly is the product? I say, okay, num of 0 for any particular number ni, right? It is the product of all the numbers from n0 to ni minus 1 and all the numbers from ni plus 1 times, let's say this is last number, which is n of n minus 1, whatever, right? So for each index, if I can calculate all the product of its lefts and all the product of its right, so for this was here I had ni, right? This was my ni element. So this is like, okay, this is my left product, okay, and this is my right, correct? So if I can calculate this in efficient way, which is what we are going to explore in the solution section, I can optimize my solution in order n. What I can do is I'll traverse from left to right, keep calculating the left part of the solution for each I, and then will travel from right to left to keep track of all the rights, right? And then I get the overall sum by overall product by multiplying lefts and rights. So which is like, okay, the first solution will be order 2n memory. It will take order 2n memory, okay, and then we can optimize it to have order n, right? So let's jump to the code and try to understand all these solutions. So I will not go into this first solution where I'll do all the product and then division, because this is definitely not following any constraints the way they are asking us, but still I will solve this one where we'll do the zeros code, right? So let's jump to the first code, which is, okay, I will count the total number of zeros, I will calculate the total number of total product overall, right? So what I say is, okay, for num in nums, if num is 0, then I will count total number of zeros, right? Otherwise I'll keep multiplying everything. Product multiplied by what? Num, right? So now if my total number of zeros are greater than 1, which means okay, for every element there should be 1 in the prefix or suffix, right? In that case I will return 0 times length of nums. This is my answer. Otherwise what I do is, for I in range of length of nums, for each of the number, right, first I check, okay, if zeros, total number of zeros were 1, because now it will be 0 or 1, right? If the total number of zeros were 1, right, I say okay, if nums of I is equals to 0, correct, if this particular element is that 0, right, so then nums of I should become that product, else nums of I should be 0. So what I'm trying to say is, I'm going left to right. If there was 1 0 present at the index when the 1 was present, my answer will be the entire product, because I'm not considering 0. Otherwise 0 is the answer, because 0 will be coming somewhere, right? But if the total number of zeros were 0 itself, like there were no zeros, then it was a normal solution. So what I can say is, okay, nums of I is equals to product divided by what? My nums of I, right? So I will return nums now. Let's see if it works. Okay, I'm getting zeros of I somewhere I made a mistake. Okay, if 0 is equals to 1, right? Okay, let's submit it. Awesome, it works. So now let's start optimizing this solution. Okay, this was like, of course this is not following the constraint because we are using this division operator, but still it's good to know this solution. And now let's do the simple solution where we'll track left and right for each particular index. So what I do is, I will say my left is 1 times, okay, let's calculate the total number of elements. My total is length of, let's get rid of this 2, let's take it to the bottom part. Okay, yeah, so now I have total number of elements, right? And my left is this so far, and I will calculate prefix for I in range of total. Okay, for each element I will calculate its prefix, so my left of I will be prefix, and my prefix now should include this item because I have to add it to the next number, right? Prefix multiplied by nums of I. So I've calculated prefix, and now I need to calculate suffixes, right? So let's do that. I say okay, my suffix is 1 so far, and now for I in range from, and reversed range, let's say reversed range, okay, till total, right? This is my reversed range, and because I'm traversing right to left now, so my right of I will become suffix, and let's include current element for the suffix now, because the element to the left is waiting for this guy, right? Nums of I. So now I just need to iterate and sum product all the prefixes and suffixes, right? Which is for I in range of length of nums, my left of I is equals to left of I times right of I, and I will return left of I. Okay, sorry, left. Okay, let's see if it works. Let me just first check it. Okay, the right is not defined. Right of 1 is 1 times total. Sorry, I guess I missed it here. Yeah, okay, let's submit it. Awesome, it does. But we can optimize it again. How? We don't need, we are trying to optimize this right section. So in this case, okay, let's get rid of this part. This was itself here. So in the next solution I will use the same code exactly. Let me copy it here. Okay, but I don't need extra space of right. What I can do is I can just take this suffix and I keep adding it to the answer whatever I have so far. So what I say is, okay, I have left of I, why not multiply it with suffix right now, because I already have answer, so I don't need the extra space there, right? Extra right space, extra space for right element. So now this will become nums of I just have the answer, because answer I already I needed all the time, right? So let's see. Okay, let's submit it. Awesome, it does. So these are all the possible solutions. I was looking at all the blogs and also I found all these solutions. So I hope guys you like this, and remember, work hard. There's no substitute for hard work. Okay, see you guys in next video.